All right, hopefully you guys can hear me all right. We'll start getting into it. People keep on arriving. So today we're going to try to keep it to around 30 minutes. Computer and phone audio is available. Everybody's a veteran by now. You can use the chat, and the questions will be at the end. And we'll try to get your questions answered. So today we're going to do a quick review on some key topics. Some new people are joining. We appreciate that. Talk about the SHA, the simplicity of it. Do a little deep dive in regards to hydraulics going to electrical. Look at both sides of the situation there. We'll talk about some marketing, and then we'll wrap up with a couple applications. And again, feel free to ask any questions through the chat, etc. So a quick review, the SHA itself is what we call the smart hydraulic actuator. It's a combination between hydraulics as well as electrical, the hydraulic benefits. Very powerful, reliable solution. Hydraulics have been around for a long time. We're taking advantage of the seal technology, etc. IP ratings of hydraulics are very strong. Vibration shock, jam tolerant. Hydraulics have a lot of capabilities there, as well as some configurations we're going to be getting into. And then we add the benefits of electrical. On-demand power. It only needs power when it's moving. A lot of versatile control capabilities. Field bus connectivity. Of course, no hoses or leaking hydraulic fluid. Very cost-effective solution the SHA is on the low end as well. It really gets very cost-effective on the higher end, about 5,000, 8,000 pound force. Some of the challenges, of course, is the speeds at higher loads. Just those horsepowers are significant and massive motors. The other challenge is communicating that the somewhat perceived complex, when you look at the SHA, it can be simple, and we'll talk about that as well. One thing that we're trying to make it simple is the all-in-one solution itself. To our knowledge, nobody else out there is really doing what we're doing, from a standard product, from low horsepower, low pound force to 84,000 pound force as a standard voltages, AC, DC, etc. So we try to eliminate that finger pointing. We spend a lot of time up front talking to the customer, talking to you, trying to understand the application. It's very important to us to make sure we size it properly. We're involved right from the beginning. Obviously, whatever information that you guys can provide is helpful in the situation. Make sure the machine, as we proceed, make sure the actuator can fit in the machine properly. There's all kinds of different ways to make that happen. We'll select the motor from hopefully our standard selection, select the drive itself, make sure the motor goes onto the actuator properly. As we proceed, again, it's electrical schematics from our standards. We'll make sure we apply the right schematics for the application, source the right drive, integrate the right drive. Harnesses are a real pain, as we can all appreciate. Some harnesses we procure, some harnesses we produce here, design and source all that for you. Produce them, and testing, make sure everything's tested here. Harnesses that go out in the field that aren't tested sometimes can cost hours and a lot of money and headaches out there in the field. Try to make sure everything's tested as much as possible here. The software itself, integration, field bus, mapping, standard programming is used. We test everything here as much as we can to the application. Of course, tuning maybe in the field is required, but at the end of the day, it's owned by Kyntronics. The only finger that's pointing is at Kyntronics. We try to make sure that everything's done up front properly, so at the end of the result is a satisfied customer. A lot of you have seen this. This is, again, important. We run into this over and over again. It's the apples to apples situation. Procurement person sees our quote and sees a competitor quote. But when we have the quote reviews, which is very important, hopefully we can continue doing that. We find out that, oh, it's just an actuator, and what we're providing is a lot more. Even if they find a quote from a distributor of just some loose parts, it's still not the same thing. There's a total fully wired solution, tested, programmed, standard program. You can even add in the load cell and amplifier, etc., as part of the cost. Adders, reliability is a cost factor as well. Some mentioned that the Kyntronics product is a niche product, a custom product. I'd like to just spend a little bit on that. So on our website, we have standard models up to 84,000 pound force. We have a standard part number string. This particular string was designed to provide a BOM to the manufacturing. So when a PO comes in, our manufacturing operations pulls down the BOM, knows exactly what's in it, and start producing it, start pulling parts, etc. from this standard BOM. We use standard parts, so they're designed to be flexible. For example, this particular one goes to 1, 1.5, and 2 inch. So the top plate's a 1 inch, so we can bore it out to 1.5 or 2 inch. This is a 2.5 and 3.25. This goes from 4, 5, 6. So we only stock 3, but we are able to go from low horsepower or low pound force to large. The same concept's done with the bottom plates, etc. So we try to minimize our inventory and our flexibility regarding the standard parts. Standard mounting are used across the line as well. Standard motors, so we use the same motors are applicable. We have the settings for these motors, cables, etc. So we try to do the standard over and over again. Standard drives, the M700 from Control Techniques, M750. Same program goes into those. So I guess what we're saying is it's really not a niche product. It's a standard product. We try to standardize as much as possible. Standard means lower cost, lower lead times. Standard programs proven it's reliable. Make things happen out there properly. Of course, custom, we can do it. We've done it. That, of course, adds cost, and sometimes it adds to the lead times as well. The word servos at times is somewhat overwhelming. We're trying to make that simple. So when we supply the Control Techniques drive, the customer does not need to get into the software, doesn't need to download the programs. They can, and we've done that before with them, and we can do scope traces and things like that, debugging and helping them on their machine as needed. But basically, if it's a field bus, this is just an Ethernet IP, which is the most popular network we provide. You just have to worry about a few registers. Command register, speed limit, target position, that's about it. That's all you got to worry about from the PLC's point of view. Of course, you can look at some feedback, but there's just a few registers going back and forth and to set up, and it's a very versatile concept. We provide a manual, let you know what registers you need to set up and even how to do that. One-time setup for your accel, decel, and tuning parameters, etc. So it's a standard program, goes into the M700 or M750, standard hardware, gets wired into the same registers. Again, we try to standardize as much as possible to make sure, when you purchase the product from us, the all-in-one, it's basically the same thing. So our test people understand what's going on, our field service, our support people, all are used to the same product, and hopefully the customers and distributors are going to be getting used to it as well. Some of the basics regarding the SHA. Simple, it's a closed hydraulic system. The servo motor connected to the gear pump, for example, runs clockwise, pumps fluid into the red, extends the actuator, runs counterclockwise, pumps fluid into the blue, and it retracts. The green compensates for the rod itself. Again, it's a servo. We do the closed loop control, and we size things properly. No metal binding, no mechanical binding wear items. It's a very efficient means of converting rotary to linear motion. No hoses, no thread connections. Hydraulic is a very advantage of hydraulics is this area equals pi r squared. As you can see, for example, going from 1 inch to 3 1/4, that's a 3.25 times increase, but the force increases by 10 times because of that exponential. This is the huge advantage with hydraulics regarding the force density. And of course, that's a benefit for Kyntronics and the SHA. Another advantage with hydraulics is it's just fluid moving around. So you can do clever things with the configuration to fit in a machine. There's a lot of different machine orientations out there, and we've done all these and more. These are our standard configurations, and it's just moving fluid. So you can have a spacer block, XX inches, an inch, 2 inches, 4 inches to get this around a certain barrier inside the machine, etc. So this is another nice advantage with hydraulics, just moving fluid around. Going electric, hydraulic is that they're trying to get rid of. They say, hey, you're adding electric. We're trying to get away from electric. But the point is that there's not a lot of fluid inside the Kyntronics actuator. For example, the 10,000 pound force actuator 8-inch stroke is only around 14 ounces compared to about 120 ounces just with a 5 horsepower gearbox. So even if there's a catastrophic issue, a tow motor runs into the actuator, you just get a mop out and pick up the fluid and move on. So going electric, hydraulics went electric. This has it's been a strategy for the EMAs to go after the hydraulic world, and some OEMs and some end users are somewhat demanding to get away from hydraulic for all kinds of different reasons. There are two different worlds. The EMA world is different, servo-oriented, position control, force control, different way of going at moving motion. Hydraulic is a different language, different way they go at moving motion. And somewhat the lines are somewhat challenging to cross. EMA sales and application guys, they don't know necessarily all the hydraulic ins and outs. There's a quote from one of the websites out there, all you need is a phone and a ruler to convert hydraulics over to electric, which that's pretty much says it right there. Hydraulic engineers may not know all the electrical side of things, the servo needs, the servo control, etc. The end result that many times is an unhappy OEM. We're running into them and we're helping them out. So before I get into some of the things to look out for and to ask about, just wanted to dig into what are the benefits and challenges of hydraulic system and electrical. Some of the benefits we all can appreciate, they're very powerful. High force density, I already mentioned that. Simple force control, force equals area times PSI. Fast speeds are available with hydraulics. They are reliable. Yes, they leak, but you just change out a hose here, do this or that, and keep these things running. No brakes required to hold position, of course. Vibration, side loading, impact, jam, ingress protection. All those are benefits in the hydraulic world. Yes, some of the challenges, they're noisy. They're not all that efficient. It runs all day long. Somewhat challenging to do precise control, weight, especially on mobile applications. Restrictive control valves, heat, controlling capabilities, footprint, expensive footprint in plants. Of course, you have the leaking and environmental issues. There's a lot of benefits with hydraulics. Electrical benefits, of course, it's all electric. Efficiency, it only runs when demanded. Control versatility is the major benefit with electrical characteristics. Field bus connectivity, of course, the no leaks. Some of the challenges, the reliability side of things. Ingress protection, they're only a lot of times rated for static, not moving, heat, duty cycles, maintenance issues. They have to maintain, make sure there's grease in there. They get really expensive on the larger horsepower above 5,000, 8,000 pound force. Very challenged with side loading. They don't like that at all. Vibration, jamming, impact loads, all are negatives for the gears, metal to metal wear, stroke length limitations, the screw buckling issues on the longer lengths, and they require a brake to hold position. So knowing all that, what are some of the things you need to consider when you're a hydraulic person, what to ask the EMA supplier? These are just some of the questions you may want to consider. Expected life, challenge the EMA supplier for the expected life. If you're a hydraulic supplier and you know your customers wanting to go electric, these are some of the things you may want to educate them on or even get involved, and of course get us involved. Machine dynamics is important. Some of the hydraulics, they just run in a velocity mode, a certain speed, putting fluid into the cylinder at a certain rate. So they have a control valve doing that, and they go down and hit a relief valve, possibly for a press application. We ran into several of these type of applications that the machines aren't all that perfectly aligned. They're binding. Hydraulics are powerful. They plow right through it, no problem whatsoever. You put a servo control, the servo is trying to regulate position. You get this binding, the servo, overcurrents. You get the spiking when the binding goes away, so you get this jerky motion, and the end user is like, what the heck are you giving me, this fancy servo, and it's binding all over the place, jumping all over the place. My hydraulics just work perfect. So these are just things that need to think about, consider. Of course, we do that. We understand that world. Another question is the IP rating, again, while moving, of the EMA itself, overall efficiency for you to understand the horsepower. Heat's an issue, maintenance required, any cooling required for the EMA regarding the duty cycles, understand the shock loads, jamming, impact loads, etc. From the application itself. Try to understand the horsepower, what's quoted. If you're an EMA supplier and going over to the electrical world, these are some of the things that maybe asked. What's the HPU's motor horsepower size? If it's a single cylinder, it's a good baseline for you to understand what's being quoted. What's the max extend, retract, pressure and speeds, cylinder rod size, cycle time, any side loads or impact loads, understand the machine dynamics, understand the control. What's happening in the hydraulic world? Is it open loop? Is it closed loop? What are the valves out there doing? What's the desired control? What do you want out of the system? Understand the machine itself. Overriding loads, another characteristic. Is there a counterbalance? Is there something going on? You might need dynamic braking resistors, locking valves. These are all some questions the electric supplier should be understanding. Hydraulic basics from the electric supplier's point of view. Retract force, extend is always less than extend force on a single-ended rod. Retract speed's always faster. So sometimes it's an advantage in hydraulics, of course. In most applications on extend, you need the higher force, and that's perfect regarding the larger area on extend mode. Dual rods, they have identical force and speeds. Simple calculations regarding, it's nice to know if you're moving a certain mass over a distance in a particular time, that's power. That's work being done. It's converted to watts. Understanding your efficiency. So if you calculate this thing should be 15 horsepower and somebody came in with a 7 horsepower EMA quote, you know something's wrong there. Something needs to be reviewed. Does it make sense? So this is just some basic calculations that one should do regarding, again, basic horsepower moving from point A to point B in a certain time. So when going electric from hydraulics, definitely get us involved. We understand what questions asked. We understand both technologies. We produce both technologies. We've replaced several hydraulic systems out there. We ask the questions. We do a deep dive. We understand the issues regarding the servo and the control and the dynamics on the machine. Make sure the actuator fits on the machine. We understand the control needs, what's happening today, what do you want to accomplish in the future, and we work with you and the customer to make sure that that happens. Just to review the same thing we showed before, SHA Characteristics again combines the benefits of both electrical and hydraulic. It eliminates a lot of the headaches from both of those technologies. So a lot of benefits with the SHA Characteristics and the SHA itself. Changing gears a little bit regarding the tools. We mentioned it in prior webinars. Rockwell AOI, it's starting to get a lot of good traction. We're available for your customers or even distributors to go through a deeper dive into the AOI itself. The AOI does, it takes that program that we've been developing over years and places it into this single AOI. Thousands of lines of code is placed in there, position control, force control, position with force limiting, etc. That's all available. Gives you a lot of versatile hardware connectivity. You can go into the PLC, you can go directly into the drive itself, position, force control. Again, a lot of versatile hardware options. Another project that we are working on with Rockwell is a press offering. So if you're interested, or if your customer is interested or desires a total Rockwell solution, HMI, panel view, etc., drive, PLC, that's being developed along with the Kyntronics actuator, of course, using the AOI. So if you have somebody out there that is interested in a press offering and interested in moving this forward, obviously projects and orders push things along both in Rockwell and here, and let us know how we can help. Marketing, we continue to add material to our website. We encourage you to check that out. Application success stories continue to be added. There's new videos out there. We're continually looking at SEO, adding various keywords. We're trying to be on the first page, top 5 or so, and generate leads for you. Follow us on LinkedIn. Provide a link to LinkedIn or our website, on your websites. These are all good things to generate activity and keep us on the top of all those Google searches. So yes, today is some crazy times, and many are home, many are not out there selling, and are hearing all kinds of doom and gloom from various sources of the economy and how bad it's out there. But there's various aspects that are doing well. So what's active today? What businesses are doing well today? So of course the food, everybody's drinking, the paper, canned, hard goods, recreation, real estate, home improvements are booming. some segments of the medical as well as military. So what is that? Go into the various industries. Packaging is having a tremendous year this year. All kinds of business and activity there. They're having challenging to keep people and hire people. Paper processing, glass bottling, extrusion, metal forming, a lot of presses for home, as well as automotive, etc. Dry ice. Pfizer's vaccine requires dry ice. It requires refrigeration. So who are the dry ice manufacturers? How are they manufactured? Who are the machines? We're doing some business with them. Again, refrigeration units, all those kind of things. Think about lumber is booming. It's hard to find lumber. Medical, military, boating was a tremendous year. So these are just some things to get you guys thinking. These are all various industries that are doing well, and looks like they're going to continue doing well. And think about various locations of these industries in your backyard. So this is an example of automotive industry. This particular one we sold a couple of years ago. Wanted to use this as an example of a roller screw replacement. This particular roller screw was failing after months of over and over again getting replaced. They went to us, bought a few of these. They just bought some more just recently. The EMA was $14,000. The SHA was $9,000. It's a significant decrease. The SHA has been lasting for years. They love it. Again, they just bought some more. This was at a 5,000 pound force actuator, so we're very competitive in that low end. Again, this is a total solution. We are talking apples to apples. It's a very competitive solution. So some recent installations. This is going to be a little video, a minute or so video showing you a little military application, some packaging, lumber, as well as a home improvement. This first one you can see is like a pipe cutter. You have a cutter and some rollers. They needed precise control cutting into this. They didn't want to go too far or you have some issues. This is in the packaging world. We're pushing up from the bottom. Again, the packaging industry is doing very well. This particular one, they replaced a hydraulic solution with this simple little actuator being installed on the bottom. They love it. Increase their efficiencies. And this is a lumber application. A large saw that's being lifted up and down, replaced electro-mechanical actuator. Lumber industry is booming in various segments of the nation itself. Something to consider. This is in the home improvement world. This is a 60,000 pound force actuator. There's another actuator in the back. You can see this place is clean. They replaced hydraulics. This is precise control, again, 60,000 pound force actuator. This is for bending a hinge, regarding, again, precision control. You never know what's in the backyard and what can be applied with these actuators. So that's pretty much it. When you are having that customer come to you, asking to inquire about going electric from hydraulics, make sure you get us involved. We'll take care of the customer, make sure it's done right. We always are trying to make the complex simple. All-in-one solution is very important to us. It's a way to make that simple. Again, it's a versatile offering, very reliable, efficient, very cost-effective solution. Anyone?
Hey, Carl, there are some questions in the chat screen.
Okay.
I'll just go through those real quick if you don't mind. A question came up about field bus protocols and are there any limits in terms of who we can talk to? And really there is no limit at all. All your standard industrial field bus interfaces are available. Somebody had mentioned CC Link. That might require a special gateway. That's the Mitsubishi protocol, but otherwise it's just a standard option in the drive to select whichever protocol you want. And then they were asking whether we can use Siemens motors. We can use really any third-party motor and drive to run the pump, and we'll specify what input speed and torque we need from that third-party motor in order to deliver the linear speed and force that you need out of the actuator. And we'll likewise provide you with a mounting plate for easy mounting. So that's, both servo motors, which we use because they're low inertia, very dynamic response, snappy performance, but you can turn the pump with an induction motor, and we have quoted applications for what we'll call lower performance solutions that would use an induction motor and even a open loop VFD.
Yeah, let me jump in. So
Yeah, go ahead.
yeah, so looking at some of these questions, field bus, pretty much any field bus is available. Obviously, the Ethernets are the most popular. And if it's not available, there's a bridge and things we can do. Like Mike said, we can use any motor. Siemens, definitely. Press solution with Siemens. Love to work with you on that. The AOI itself, the program itself, maybe there's something we can do regarding its Characteristics. So if there's something we can do together, that's definitely something that we can work again together with. Any motor, yes. Most competitive against electric actuators. When you get above that 5,000 pound force, 8,000, we start getting more and more competitive up that line. You're talking 20,000 pound force, even 30,000. We're 4 or 5 times more cost effective than electric actuator. And when you get into force controls and things like that, more sophisticated controls, we're very competitive even on the very low ends because we don't need a load cell, etc. And yes, the presentation, we can provide you a presentation. It'll be on our website as well, this webinar. Safety rating. Yes, we can meet various safety ratings. Let us know what you're specifically inquiring about. We can give you that detail. The heat. Yes, the heat, try to size the actuator accordingly for the application and duty cycles. We use fans on the pump. The pump is the hottest point. We use 2 fans, large fans and heat sinks to get rid of that, and it works very well. For really high duty and high load, high pressure applications, worst case scenario, we'd use a cooler. But that's very rare. So usually the fans are just takes care of the heat itself. Can we coordinate motion with multiple axes? Absolutely. There's several videos on the website showing that. We just shipped a 4-axis coordinated motion. You can get up to about a half a thou coordinated together, or even better, depending on the network. Any plans to offer a single actuator solution over 80,000 pounds force range? Yes, if it's a proper, we try to stay away from the custom, but if there's multiple, we'll do that. The 80,000 pound force is a 6-inch, going to a 7-inch. Inch is custom for us, but it's not that big of a deal. It's the same pump, same power unit. So if the application makes sense, we'll do that. Offer smaller versions. The smaller version is the 1-inch. That's pretty much the smallest standard, and it's competitive. We're competitive, and And yes, we can use a stepper. And of course, we're not going to be competitive against a simple little ball screw type thing. But if there's some little more sophistication required, that's where we really shine.
Especially on the longer lengths, Carl, right? Where you have column buckling and issues with screws where you have to
That's right.
do a lot of mechanical reinforcement.
That's right. So yeah, a lot of good questions. I don't know if I missed anything. And if I did, just contact your sales guy or myself direct, and we'll take care of you one way or the other. Anything else, gentlemen? Again, we appreciate your time and have a great Christmas and holiday season. And hopefully 2021 is going to be a hell of a